There are other things that you have been taught over the years that's also important for you to know to solve the geometry. So I've just highlighted some of them. I know this is what you know, but I thought I'd just make sure that you understand it. So I always tell students to check keywords, right? So for example, whenever you see the word diameter, you must immediately respond by finding the 90 degrees, right? Diameter must give you a 90-degree angle. Whenever you see the word tangent in the question, whenever you see tangent, you must immediately respond with number 8, 9, and 10. Now remember, the numbers are not important. I'm just saying 8, 9, and 10 so that you know what I'm referring to in terms of your toolbox and the way you're thinking about your theorems, right? So tangent, you have radius perpendicular to tangent, angle between tangent and chord, and you have two tangents, right? So that's your tangent. O, and can I say to you that sometimes some of the students lose points or marks just because they miss something like the radii. Now, if you miss the radii in the question, what do you actually miss? If you check carefully, there's your radii, because O is the center of the circle. Whenever you have the center of the circle, tick your radii. Why? Because sometimes there may end up being a isosceles triangle. So if two sides are equal, then the two angles would also be equal. Alright? So it's easy to miss it. Make it a habit. When you see the center of the circle, look for the radii and indicate that. Alright? So that's the response. Also, when you get AB is parallel to CD, or if you get two lines of parallel, find the F, right? You see the F is laying down a bit, but these are corresponding angles. All right, so that's the one. Then you have the Z. You can see the Z. It's a nice, definite Z. There are your parallel lines. The one angle is this side, the other angle is on the other side. Alternate angles, and we know that alternate angles are equal. We also know that corresponding angles are equal. Right? So that's stuff that you should know. I'm just reminding you how important it is. You also know that these are co-interior angles here and there, and the relationship with co-interior is that they are supplementary, or they add up to 180 degrees. Angles on a straight line, also 180 degrees. If you see the word cyclic quad, your response should always be number 6 and 7. Opposite angles are supplementary, and exterior angle equals interior opposite. Right? And then you also have your triangles. You have your scaling triangles, but we know that the sum of the angles of any triangle add up to 180 degrees, so that's the one property. You have your exterior angle of a triangle is equal to the sum of the interior opposite. Right? And then, of course, you have your equilateral triangle, and sometimes students know that they are all equal, but you also need to know that they are all equal to 60 degrees, right? So that will be 60, 60, 60. If you add the 360s, you will get 180. And then, of course, you have your isosceles triangles, and these angles at the foot of those equal sides. See there? At the foot, that means they are equal. All right? So that's just kind of taking you a little bit down memory lane, because that stuff you have been taught, that's mingled with what you just done earlier. All right? Now the next part is, for me, one of the most important parts, because it's no use knowing your theorems and you don't know how to apply it. All right? I just spoke about the dot C dot approach. What do I mean by the dot C dot approach? Very, very simple. And in this way, you will always get your angles that are equal. And I'll show you how it works, right? So in one of the problems, the second one, that's where you should use it because it's very easy to pick the wrong angle. All right? A lot of students, when they look at it, they want to give the answer. I said, don't just look. Make sure you have a strategy so that you find the right angle. Because there's such a lot of lines that confuses people. All right? So, dot C dot, whenever you have a chord, right? Whenever you have a chord, put a little dot on that chord there and a dot on the other end. You see there? Two dots, right? So you know that a lot of the theorems work with the chords, right? So from here, you can take a line to the center, that's a C, a line to the center of the circle, and then back. Then you know this is the angle at the center, right? But you can also get this line going to the circumference, and then back to the other dot. Then that's the angle at the circumference. So it's always dot, C, which is the circumference, or the center, and back to that particular dot. You with me? All right. So, why did we struggle with this? So why did we struggle with that one, right? Now, I always say to students, if you know your toolbox, you should immediately pick up the points without even much deep thinking. No? Now, if you look at the problem, here, you see here, it says chords AB and CD. So it's the center of the circle, O, and it intersects at M. Now, they didn't even need to say that because you should be able to look at the sketch and say, there's a chord, AB, that's a chord, right? Or CD, that's another chord. Right? So this doesn't help you that much. All it does, it tells you that you're working with some chords, right? A lot of students struggle with this word prove. Don't be afraid of it. You have the tools to solve the problem. Doesn't matter if we say calculate, find the angle equal to x, or prove. It's the same toolbox. It's not a different toolbox, right? So there's no fear around the question. You with me? The half is a fraction. Don't be afraid of the fractions. A lot of students hate fractions. But I know you guys love fractions, right? You hate fractions? Right? I know we hate fractions. We tend to dive to our calculator to help us a lot of times, right? But don't be afraid of the fraction. But now, what is important? Are we given an angle? Yes, isn't it? Look, I'm not looking at what we must prove. I'm just checking what's there, what's given. And what's given is they're talking about an angle AOC. Your first response is to go to the sketch and see where is this AOC. Now, if you check carefully, AOC, isn't it? So what is this? AOC is an angle at the center, isn't it? So there you have an angle at the center. What must your response be? Find the angle at the circumference, because you know what's the relationship, isn't it? So here you have the angle at the center, right? Where's the angle at the circumference? So first, dot on C and a dot on A, right? Because that's how you need to center and C, right? Now you check, is there another line going from C? Yes, there we go. And it takes you to the circumference, which is D, and then you get back to A, isn't it? So immediately you can say angle AOC is equal to 2 times, this is B1. This is D1 here, right? And that's obviously A2. So angle at the center is twice the size of the angle ADC. And if you write it, right? And if you write it, remember you don't even know why you're writing it or why you're solving it, but that's how you start the problem from what's given. So you will write angle, I hope you guys can see, angle AOC. I'm leaving it in case you can't see it, right? Angle AOC is equal to 2 angle D1, isn't it? It's twice the size of angle D1 because you got a theorem, and we know it's number 5 in that toolbox that deals with the center angle. You have found the angle at the circumference, and you will write angle at center. Remember, always give your reasons. Equal to angle at circumference. You with me? And in the exam, we will do 1, and you have 2 points. Thanks. Does that make sense? Right? Again, it's nothing magic, right? It's about what you know, and you know how to use it. That's your strategy. And then see what's given, and you apply it. Now look at the second part. What is BOD? BOD. Here's B, there's O, and D. So O is already a clue that it's the center of the circle. So what do we have? We have another angle at the center, but in this case it's BOD. You with me? Now, BOD is the angle at the center. Put your dot on the B and put your dot on the D. And then see if you can move from B to the circumference, nowhere else but the circumference. So from B, you move all the way to A, you see that? There, and from A you get back to D. So A2 here is the angle at the circumference. And all you need to do is make sure you write it down because you're using your information, and you would say angle BOD is equal to 2 angle A2. And it's the same reason. And what do we do as markers? We say, well done, 1, 2 marks. You already have 4 out of 6. And you can say, I've got 4, I've got more than 50%. Now I don't have to worry. I used my toolbox and I got the solution, right? Or part of the solution. Remember, I said, make sure that your processes are in place. And what are the processes? Know your toolbox, know how to use it and apply it, and that's where you get the marks. All right? Sometimes getting the answer is a little bit more tricky, but at least you've picked up the 4 easy ones, right? And that's how you need to look at your question. All right? See where you can score, and you can score by using your geometry toolbox. All right? Now, how do we solve that? Just quickly, if we want to. You can see here that, and I can take you through this solution just very quickly. So if you check very carefully, here you've already got the 4 points, right? And all you're doing here is saying angle AOC plus BOD. How do I know I must write that? Because they do it there, right? It's not rocket science. It's there. So you know you must add the 2, isn't it? So if you add the 2, AOC plus BOD, which is the left side here, then you must also add the other side, which is then 2 angle 1 plus 2 angle 2. All I did, I took out 2 there and I grouped 1 and 2 together, right? And here you can say A1 and 2, but you can also use angle 2 and angle 1 because it's clear enough to use in that particular way. How do I get the half there? You multiply both sides by a half, or you divide this by 2, isn't it? And therefore you must divide this 1 here by 2. And that's how you get the half, which is then that. Which is equal to angle 1 plus angle 2. Now, angle 1 plus angle 2 is the exterior angle here. You see that? These are the interior opposite angles. And that's equal to the exterior angle of the triangle. This is a triangle. That's the exterior angle. The exterior angle here, AMC or CMA, that's the exterior angle, is equal to the sum of 1 and 2. And they solve it. But I say to the students, sometimes that will be a little bit more tricky, but this, you can't throw away the marks. Right? Because part of what we want to do here is to make sure you understand that you can pick up marks in geometry very, very easily. And the reasoning that you use is the reasoning that we had earlier on. As you say the stuff here, for your toolbox, that's your reasons over here. Angle at center, 2 angle at circumference. All right? So, colleagues, facilitators, just at your table, make sure that the students are okay with this thing, with this one. Very quickly, to just make sure that they're all on the page, they got all the right angles in place, and then the other quickly. Just about 5 or 10 minutes we need to do that. Make sure they apply the strategy if they're struggling to find the angles. All right? Thanks, colleagues.
want to know what kind of am I copying this again?
You're using that example. It says if this angle equals that, what is the reason?
Do I just write calculate theorem or I have to write?
You have to write the real reason.
Oh.
It might not be it's not turn code everywhere. But you must write the reason for your argument. For instance, you said that T1 equals FC. What is the reason? So write the real reason.
You mean the long statement?
The reason. The reason.
And like this.
Is it the way we write the reason? For third one? I know how to write the reason. You must know that the reasons are given a mark if you have said it exactly correctly. You might be knowing that it's turn code and you just write it haphazardly, but if you did not write it correctly, you will miss that mark. I'm saying something to this one. I have just said something to this one, your attention a little bit. I was saying to this, she was saying, do I write turn code theorem? Do I write what? Here they write a tangent, that chord, what, ne? And I was saying, the reason must be exactly correct. If it is not exactly correct, even if we can read and see that you are close to it, if you did not state it correctly, you miss that mark. So if the mark is there are two marks, the one is for the statement, another one is for the reason, you will get a mark for the statement and not for the reason. But sometimes there is one mark for both the statement and the reason. So if your reason is, then you miss it. For instance, you say opposite sides equal angles. I'm just giving an example. You write opposite sides equal angles. We see that you want to write what there? Angles opposite equal sides. But you did not then, but we can see, but we still don't give you the mark. Okay?
Hey, yes. This one. Yeah. Yes, we have problem with
Okay, level 7. Can I have your attention again and colleagues? Obviously, we don't spend the whole day with geometry. I want to pull things together. We want to end geometry at least by lunchtime. And after that, we'll do trigonometry and calculus. Okay? So there's still some stuff I want to cover. So I know you're busy with the strategy, but can I have your attention? Right?
at the circumference, we go and trace AF
So,
to another circumference. It forms what? It forms.
alright, I see
You see
quite
that one?
few
Yes,
tables are
now
still busy.
angle O2 is 2 times angle B2.
Colleagues, we still need some more time. I'm just worried because we have 1 hour before lunch. And I want to get into the similarity and the ratio of proportions quickly.
I want to add O2. I want to come out O2 is 2 times. Moreover, this is the angular center. O2 is the angular center. Then let's look at angular center. We go straight to the section. O2 will be formed by AF. Arc AF. You see that one? That one is K. This is K. That is an arc.
Alright, can we go in?
This O2.
Alright, I need everybody's attention because something different. We're going to move from our toolbox to making our toolbox complete. Alright? So let's check. By the end of today, this is something that you all need to make sure you know, okay? So that's important. Now, there's still 2 gaps. This one here and that one there that we must fill in. And once we've done that, then you have your complete toolbox for the final exam. Alright? I still need everybody's attention, guys, quickly. Alright, I hope the guys at the back can see, but otherwise I'll talk you through it if you can't. So, this is something I know you have already probably covered with your teachers. So it's again just a very quick recap and a summary of the important parts that you must know. Now, the biggest problem with this section is the fact that we're working with fractions, right? Now, remember what we said right at the beginning. No fear, we see it as a challenge and we overcome that, right? The fear of fractions must be gone, right? Because it's not that massive. Some of the ideas is things you in primary school, and it's the same thinking. They just use this funny term proportion, right? But the thinking is exactly the same, and that's what I want to just highlight and pull it together, summarize, and then you're ready to solve problems. You may not do a lot of problems here, but when you leave here, every day, I encourage you to do one problem from the exam paper, any exam paper. Just do one problem every day, and you'll see how ready you are by the end of the year. Okay, but we'll talk about that later. Okay, so we're talking about these proportional intercepts. And if you check carefully, I'm giving you a triangle here, and I'm giving you the sides. These are the measurements So whether you want to talk in terms of centimeters or meters or whatever unit, it doesn't matter. So this is 1 unit, this is 3 units, 2 units, and 6 units. All right? I've done the first one here, AD over DB. So you have to watch the pointer. AD over DB. You see that? AD over DB. And then I've got here AE over EC. And if you write in the values, AD over DB is 1 over 3, all right? And then AE is 2 over 6. And what do you know? That a third is exactly the same as 2 over 6. Now, that is not difficult, am I right? Because that is what we talk about from our primary school days called equivalent fractions. No? So you could have 3/4 is equal to, say, 9 over 16. 9 over 12. Right? It's equal to 9 over 12. Do you agree with that? Right? Now, what did we do to 3/4 to get 9 over 12? Right? You multiply this by 3, and then you also multiply the bottom by 3, because what your teachers will tell you is whatever you do to the denominator, you must do to the numerator. Or whatever you do to the numerator, you do the same to the denominator. Now that idea is exactly the same as we have with proportional signs, right? If you check here, now we don't talk about working with the times 3 and times 3, doing exactly the same, but we use the same principle. And why can we do that? Because of equivalent fractions. So AD over DB is equal to AE over EC. A third is equal to 2/6. So we know that. But what is important is the fact that the jumps here, AD over DB, must be exactly the same as the jumps on that side. So here we start from A to D and then D to B. You see that? Here we must go from A to E and then from E to C. The jumps on the one side must be the same as the jumps on the other side because it satisfies our equivalent fractions. Whatever you do to the numerator, whatever you do to the denominator, you must do the same. All right? So just quickly, if you can see, find AD over AB, AE over AC, and make the deductions as we did there. All right? And then the same with AB over BD equal AC over CD. Right, you should have that right. 1 over 4 is equal to 2 over 8. Right? And then of course the other one, AB. AB should be 4 over BD, which is 3. And that's the same as AC, which is 8 over 6. All right? So again, these fractions are all the same. All right? Or they are equivalent to each other. All right? And there's a reason why those are equivalent. Can you remember, everybody? What's the reason for these fractions being equivalent, right? Or proportional, if you want to call that. There's a reason for that, and the big reason is the fact that DE is parallel to BC. That's the only time you can get the sides being proportional if those lines are parallel. And that's the important part, okay? The other thing that I want you to know, because it's important for calculations or computations later on, that if you have 3 over 4 is equal to 9 over 12. You can play around with these fractions that are proportional, right? Or equivalent, if you want to call that. You can interchange it. Then 3 over 4 can be written as 4 over 3. But whatever you do here, you must do this side as well, isn't it? If I flip that fraction, I must also flip this one. So that becomes 12 over 9. All right? But I can also cross multiply. 4 times 9. 4 times 9 is 36. 3 times 12, also 36. So you can cross multiply and you will always end up with a true statement. And that why I'm doing that is because in a lot of your calculations later, it's not about numbers. It's going to be about letters. All right? And that's what makes it a little bit more tricky because you may not see what's equal and so forth. Okay? But we'll do an example of that. All right. The second one I want you just to look at is that now the equivalent fractions don't look so straightforward, am I right? Here you can see it easily, but you're going to be working with decimal fractions or bigger numbers as well. You must be able to work with that. So if you check, again the sides are 5 and 2, 6.25 and 2.5. If you take BD, here, note the jumps, BD over DA is the same as CE over EA. All right? And if you use your calculator here, just to check, 2 over 5 is 0.4. CE over EA is 2.5 over 6.25. If you divide that on your calculator, use your calculator, then you have 0.4. What does that mean? That these fractions are the same, right? In other words, they are equivalent. In other words, they will give you exactly the same value. All right? So there you have BD over DA is equal to CE over EA. And your reason, the jumps on the one side is exactly the same as the jumps on the other side. All right? So, okay, just do that one quickly. BA over AD and CA over AE. And see what you get. All right, so just to cover that quickly, so you've done BA over AD is equal to some fraction, CA over AE is equal to some fraction. What did you get here? 0, 1, 4, and here 1, 4. So you get exactly the same. Therefore, these fractions or these what you want to say sides based on the jumps are all the same. Okay. Again, jumps on the one side, same as the jumps on the other side. Why is that the case? Because the two lines are parallel. Right? Now, maths has a habit of messing us around sometimes, right? Because that's really straightforward. But we can also put the parallel line outside of the triangle there and connect things like that. But because these lines are parallel, we still get proportional sides. But the secret again is your jumps on one side must be the same as jumps on the other side. So you can forget quite a few things, but in terms of proportional sides, you need to remember jumps must be the same for the two sides. Okay? If you leave with that knowledge, then you're on a good way of solving our problems later on. So if you check here, AD over DB, there's AD over DB. So it's AD over DB. So that would have to be AE over EC. And that's how you get 1 over 4, 1 comma 5 is 6, and you get again 0, comma 25, 0, comma 25. So you again will get equivalent fractions. So just test if that's true for those jumps. BA over AD and AC over AE. And then we can put things together quickly. All right, and if you've done that correctly, you'll get the same value, isn't it? What's that value? Say again? 3. All right? 3, 3, and those sides are equal. So what is it that I want you to get? Don't worry about what we've just done in terms of the numbers. That's just to get to the deduction, right? This is an important little sketch. If you want to take that down, it's important because it shows the jumps, right? A different way we can jump. If you have colors, it's even better. So AD over DB is the same as AE over EC, and that's what you would write down. Why? Because the lines are parallel. You can go AB over BD is the same as AC over EC, right? And you write it down. Those will be your proportional sides. Similarly, you can also go AB over AD, then it will be AC over AE. Jumps on the one side must be the same as the jumps on the other side. And you cannot go wrong with these proportional theorems, right? Or application. Right, so if you want to quickly just note your jumps, I'll give you a minute to do that. and why I want you actually to write it, do it, is so that you can actually physically do the jumps, right? So that you can see that it must be exactly the same. All right, so that's the one type because DE is parallel to BC, so you get those proportional sides. Jumps on the one side, same as the jumps on the other side. Even if we have this one with the parallel line on the outside, all right, exactly the same. The jumps on the one side will be the same as the jumps on the other side. So I'm not going to ask you to do that because I think you get the understanding, right? Is that okay? Clear? Whatever you do one side, you do to the other side. That's just the summary. If you want to get the wording, the terminology right, we deal with a term called ratio. But what is a ratio? Ratio is just a fraction. All right? DA is to AB. That's called a fraction, but we can also call it the ratio. Right? And we'll pick up that later. Then we say DA over AB is equal to EA over AC. It means that the ratios or the fractions are equal, right? And then the sides, each of these sides, DA, AB, EA, AC, are in proportion. And again, we don't ask you these questions, so you don't even need to write it down. But it's just important in terms of terminology. That's where the proportion comes in. They are in proportion if the fractions are equivalent, right? As we did here. So these numbers are in proportion because the fractions are equal. All right? That's just a bit of the terminology, and this is exactly what I just said. Jumps on one side is the same as the jumps on the other side. So that's a summary of what we did. If you look very carefully, that's where we get the proportional responses, okay? If these lines are parallel and the converse is also true, we pick it up in our application now. But lastly, just to wrap up so that we complete our toolbox, right? You've done similar triangles as well. Similar triangles, the concept and the idea is not always an issue. The issue is just finding the angles that are equal because you have to prove equiangular or you have to prove sides are proportional. So think of similar triangles, not the same as congruency. Congruency, if you cut out the two triangles, they fit on each other, right? But similar triangles, you can have a small triangle and a big triangle. If you cut them out, they won't fit on each other because there are different conditions linked to similar triangles. And the first one is that the angles are equiangular. In other words, angle B is equal to angle B here, angle D is equal to angle A, and angle E is equal to angle C, right? If the angles of the one triangle is equal to the angles in the other triangle, then those triangles are similar. And how do we get these angles to be equal or check? We have to use our toolbox that numbers 1 to 10, all right? So that's what we need to prove triangles are similar. All you have to do is prove that the angles are, or corresponding angles are equal. And once you have corresponding angles equal, then we say the corresponding sides are proportional. In other words, corresponding sides are proportional, meaning these fractions are all equivalent fractions. Right? And just check. They are similar, therefore BD over BA is equal to BE over BC is equal to DE over AC. Alright? That's how we get the proportional sides. The most important thing with similar triangles is when you write triangle BDE is similar to triangle BAC, then you say angle B and angle B are the same. D and A are equal, E and C. So the order is important. You with me? If you say triangle BDE is similar to triangle CAB, then that's incorrect. It has to be in the correct order. So the order of the letters is important when we deal with similar triangles. All right? And now you have a completed kind of toolbox that you need to be able to know and use to solve any of the geometry problems. All right? We've added this one here now. Right? Where if these lines are parallel, if these lines are parallel, then sides are proportional. And here we deal with similar triangles, right? If the triangles are similar, then sides are, or if angles are equal, or corresponding angles of the two triangles are equal, then the sides are proportional. Alright? Now that wraps up your toolbox, and again, by the time you leave today, you must know that these 12 ideas or theorems, whatever you want to call them, you need to know. So I always encourage my students, and I'm sure your teachers have done that as well, is that they don't give you an information sheet with geometry, but before you start your paper 2, you write you write these 12 blocks and you see if you can fill in all of them. If you can fill in all of them, then you're ready for that exam. If you only fill in 5, you are in trouble. Alright? And that's why knowledge is not about what's on the paper, it's about what's in your head. And that's where you want it to be. Alright? And so part of what we want you to do is to know it, so that when you get back to school, you can take 1 or 2 of your friends and show them so that they can also get onto the page that you are on. Alright? So there you have the toolbox. I like throwing the toolbox all the time because it's a reminder of stuff that you need to know. But on this page, there are 2 important things as well. You see here? You know, sometimes when you prove certain things, right? You actually trying to prove the converse of some of the stuff that we have. So if you get the situation, you check it here, I know you can't see it, but if you get a sketch that looks something like that, and you can show that BCE, see there, this angle here, if you can prove that this angle is the same as angle A, right? You see that? If you can show that this angle is the same as angle A, or if you can show that this angle DCA here is equal to angle B, then you actually prove that you can draw a circle through those points. In other words, if you remember the terminology of a circumscribed circle, remember what's a circumscribed circle? Anybody? What's a circumscribed circle? Circumscribed circle? Yes. Just hear what she said.
It's a circle that passes through the vertices of a triangle.
Did you hear that? It's a circle that passes through the vertices of a triangle. All right? So, in other words, it's not given there, but you have basically proven what? Right? You have proven number 9 in your toolbox, isn't it? You proved that the angle between these two is the same as that one. Therefore, this line can be a tangent. Because the angle between a tangent and a chord, angle between tangent and a chord is equal to the angle in the other segment. And that's important, right? Once you show that, then you can say a circle can be drawn through those 2 points, and this must be a tangent. Similarly, if you prove that there's a line from M to P perpendicular to PS, then you have actually proven that this could be a radius and this would be a tangent, because that is the relationship, right? And so you can again safely say PS is a tangent. So it's a converse, and I've included that in your notes because it's very, very important, right? Because you'll find in some of the problems we're going to do that there are cases we have to prove that the line is a tangent, and then you have to do one of those 2 things, right? I think I've also got this in your toolbox. Is it there? I can't remember what I put in there now, but I think it should be there. And why is this important? Because the angle at the center, it sounds so easy, right? Angle at the center is twice the size of the angle at the circumference. Angle at center, twice the size of the angle at the circumference. But the problem is that there are different ways of looking at the angle at the center. So this is to show you the 4 different ways of finding the angle at the center, or working with the angle at the center. Angle at the center is twice the size of the angle at the circumference, and that's what you know, that's what we work with, right? But again, note, center, circumference. Here, center, circumference. A lot of students mess us up in the exam. When you give them this, they say these 2 are equal. And why are they equal? Because they're on the same line, right? They're there, kind of almost on the same level. So they must be equal. But that's not how it works, right? It's about the angle at the center and the one at the circumference. If that's the case, one at the center will always be double the angle at the circumference. What about your diameter? We know a diameter subtends 90 degrees, isn't it? But what is a straight angle? It's 180, right? This angle here, the straight angle, is double that one, which is 90. So you can look at the angle at the center there as well. And then the 4th one is the one here. It's not just about the acute or the obtuse angle, but it can also be the reflex angle. See that? The reflex angle at the center is double the size of the one at the circumference. So these are just variations of exactly the same theorem. All right? And then next to it, you will see the cyclic quad. How to prove a quad is cyclic. And that's what you need to show. Opposite angles, if you can show that opposite angles of any quadrilateral is 180 degrees, then this must be a cyclic quad. In other words, a circle can be drawn through A, B, C, D. If you can show the exterior angle is equal to the interior opposite, note what I'm doing. Exterior angle is equal to interior opposite. If you can show that, then a circle can pass through X, Y, Z, and R, right? So there you can prove that it's cyclic. And the last one, also very important, if you get the situation where a line segment subtends equal angles, you see there, HG subtends an angle of 40 and an angle of 40. Therefore, a circle must be drawn through there because only a chord subtends equal angles. So here we use 3, there we use 7, and the one above we use 6. Alright? So that is what you must know. Just keep going over it to make sure that it sticks, because once it sticks, then you know it's going to be easier to apply. And you can see in the problems how different the same things is being asked. The sketch may just be different. Alright? Okay, so we have time for a couple of exam kinds of questions. So I've highlighted which paper it's coming from so that you can see you're now working through exam kinds of questions. So here our colleagues, the facilitators, you can assist. Let them first try it, right, before you assist them. That's important. Don't help before they've tried it. They must try, they must see where they've struggled, and then link it to our theorem, right? Link it to the toolbox, so that they can see the link between the knowledge and application. All right, this is in your sheet, so you can do that. No, I think
Check by the second Monday. They just want to be sure that you are again. Check it. Hold on.
All right, level 7, just have a look up very, very quickly, all right? I know that some of you are moving quite fast, so getting through it, others taking a little more time, and that's fine. But I want you to just look at the problem, right? So there's our first problem. Are you all with me? Okay, so your answers obviously lie in the question. So if you read very carefully, you can see in the diagram, PQRT is a cyclic quad. So PQRT is a cyclic quadrilateral. All right? Now, immediately you see a cyclic quadrilateral. What must come to your mind? Opposite angles must be 180, right? And exterior angle. So now you must check, okay, is there an exterior angle? Yes, and they give it as 70 degrees. So the exterior angle here, 70, is equal to, note what I do, interior opposite. Right? As a safety mechanism, it is exterior angle equal interior opposite. So you know this whole angle is 70. And let me tell you now, if you have different colors, you can or just write it in, You've got 70 there, you write 70 in here. When we mark at the end of the year, we already put a tick there. Right? But you can't get 2 ticks because you haven't written out your reason, right? You know that the angle is 70, but your reason is not there. So if you want to, you can actually fill in here calculation and reason. This angle is equal to 70. Reason, exterior angle equal interior opposite. You didn't invent it, it was given. Cyclic chord, use number 6 and number 7. Alright? Then what's added? There are 2 lines that are parallel, isn't it? So these lines are parallel. Immediately you should think of, is there an F for corresponding? Is there a Z for alternate angles or maybe co-interior? Alright? But you need to respond. Parallel lines means I need to respond. Alright? Find those angles. Now look at this one here. That's your line, that's your line. Always start where they give you an angle. If you look at this one, you can see the Z, isn't it? There's a Z. So this is 70, and therefore, are you listening? You must help me. Alright, so this one here is 70, that's equal to 70, alright? RT is parallel to QP. So RT is equal to 70 as well, isn't it? Because that's your Z. And by the way, look at question 1. Why is angle P2 equal to 70? It's equal to 70 because of that, right? The lines are parallel, you've seen the Z, so that's equal to 70. And then P meets RT produced, okay, that's just about the lines being extended. But here's another important piece of information. QP is equal to QT, isn't it? So this side is equal to that side, giving us an isosceles triangle. Remember earlier on, I showed you about you need to know from your previous years of maths. Isosceles triangle, you have these angles that are equal, right? So if that is 70, then this must be 70. So you already have enough angles to start calculating and simplifying. So what am I stressing? 2 things. 1, use the information to fill in the answers. Write those answers on your sketch because we mark the sketch at the end of the year, right? And if you fill in all the angles here, you can at least get half the marks. You can't get all the marks because you haven't filled in the reasons, all right? Okay, you can wrap it up quickly. All right, continue with that one, and then try the next one once you've done that.
Today, today, considerate and I write a rough fair. Take a baba. What's a baba? Oh, Mama, and Navati, the Vatos Palavarana, Hidiratin. Eker Mama, and Nakavalaka, Mother, Washo committee, Metamo province in Yanayalampo. Eker Washo committee, Metamo province in Yalampo, Washo committee, the distant Tikamokajona. Teranado Tono Marako and Abufisa, opened. Wow, number and metal Dirwani. Tiana ke to mama wale ke a guru or an expert ya dipalo. O tlo reng ya tsamamo o ska mo lesa fela o ka go motsisha. Ke a former examiner ya math and now ke an internal moderator. Ya dipalo ke na bona e question paper e tla ke ra lebella gore na question paper yo e ka lokela gore re ngwana na. Ka ke a tsaba re go la ka internal moderator. Ke no ba ke na le ba ba tsa pele bo fonna la pudi. Ora le tsaba re na le matlhatsi makaka go marena ka ba no le dumedishe. Bana ba go
I just want to indicate that for you to be here, just for you to be here, and for you to meet me, and for me to meet you, I feel so privileged. Okay? Because what I know is that each and every one of us has the ability to be the best if they are prepared to do it, or if they want to. If they are prepared, or if they can take the challenge, they can be the best. And when I see you here, I see that opportunity being given to you to say, as a province, as the district, we know that if a learner can be able to do questions on their own and be able to achieve up to level 4 or level 5 or level 6 in maths, they can also go to level 7 if they want. If they can take the challenge, they can go. But if they don't want, and if they don't want to challenge the challenge, they can remain there. Okay? Yes. And I'm saying this because I also took a challenge in my life. I started doing maths in grade. During those days, we were staying standard 9. But standard 9 from 4. I started doing maths in Form 4. I was doing history, geography, and Greek, all that before. And when I went to Form 4, I changed to maths and physical sciences and left the other subjects. But because I was prepared, that's why I'm here today. So even yourself, if you can be prepared, you can do, or you can change things because it's possible. Thank you.
Maybe she left something. Maybe she left something.
Why I did maths? Why this one here, this one is my student, actually. I used to tell them when I was their lecturer at the college to say, if I find you with you STD only, being a teacher, don't even meet me in town, don't greet me. If I find you with STD only, don't come and meet me. Just find a way to dodge me and don't come to me. Because you have to do something with your STD to be worthy to come and greet me again. And they did that. That's why he's here. Thank you.
Thank you, Doctor.
All right, guys, have we completed that first one? Remember, you don't need to wait to move on, right? You can just move on to the next one. But what I want you to try and start with now. Yeah, let's do this one quickly. The second one. You busy with that one? Again, facilitators, just check that everything is going okay with the different groups.
Excuse me just for a minute. I want the second manager from Okubo just to wish you all the best.
Alala Capricorn South, alala. Alala Mets, alala. Alala Bright Lenas, alala. We are all committed. Like, so how are you doing this bright midday? Are you fine? We are so energized by seeing you being well put. You are in the right hall doing the right stuff. And we believe in you. And we are going to obtain 85% as our district target. Are we going to get there? Thank you very much. All the best.
So level 7, you can see this one, the second one, you're only working with the first two theorems, isn't it? Right? The perpendicular onto the chord, what does it do to the chord? And that's your big starting point, okay? Maybe somebody who has solved it can come and can do it to us on the board here, would be nice. Right? Somebody who thinks they've got it solved.
Is it tapi tapi?
No, you said put it here.
Found first.
Yes, I found it.
Honey, Mokia switch you off. That not. I see myself and I don't know why I see myself.
It's mine to take.
Am I in
Ma'am, the contract, are you around?
Yes, I am.
Yeah, it is your second manager.
What I did was I found stuff I started with this child and then I looked for using this.
The same one.
Okay. And then I made OT the subject of the family here. And then I left it. And then I went to this triangle again. I used it and I made OT the subject of the formula and then I repeated it. And then just like that.
Because we have this common cycle,
And you found well, another approach. I wasn't
because this is a common cycle, this is proportional to this one, hence the ratio. The one then this will be get the point. Okay? Are you sure? Then what is the we are going to talk this side. The way that it's OT over the side, then this side over this side. And this side over this side. OT.
Colleagues have facilitated a bit of a one kind of solution. So you can associate and see there are other ways of solving this problem. Once you've had a look at what you've done and how you've done it, you can okay. It doesn't mean what you've done is incorrect. But you still have to end up with 30, 15, and 80, 30, 25. There's not a lot of geometry, you'll note there's not a lot of geometry, but it's kind of computational understanding, right? Solving numbers.
Remember, here is 7 over 15 over 3. So I want to remove the 80. I'm going to divide this. So what is 22 less over 7 over 15. This is the ratio. Meaning your OS is 7 units. And then your OT is 15. Place 7, place 24, place what? 15. You can type, you use Pythagoras to find the OT. And Pythagoras, you can put it by say, shift, omega, raise it. Remember to find the radius. You have to first substitute the x coordinates. I'm using this triangle. The x coordinates, what is it? Your x coordinate is 25. Shift from your y coordinate to 7. I'm just putting the radius is 25. Whatever the angle here is 60 degrees. And then you can even use this triangle. This triangle, both triangles are giving information. You can even use this triangle to find the side. And must also give you the now go to put what? 25 so we 20.
Minus 06.
The y is what? 50 plus 25. More over to the guy who going to in the form of this. When I have to go back, what was it before? Because this over this. This is the ratio. When it's given in ratio, I have to do it. So like you're not Madam, I don't like to give up showing you this method because it's from that's why you see me just saying, give me a calculator again. Because when we invent Alisa was in China, Papa was the one which is going to get
You don't sit in the top. We especially the second fraction. Fraction as it is. Is this a plus?
All right, everybody, you need to take just about 2-3 more minutes on that one, and then we've got one problem to do, and then obviously it will be lunch. Okay. I'll tell you which one to do in a few minutes, but just try to get through this one very, very quickly. As I said, there was a possible solution up there. Yours may be a bit different, and that's fine. Remember, what we're interested in is not the final answer, which will be great, but it's the process, right? The thinking that's involved that's important.
And then you come here. I think that's to be divided into this one. You now have your own X7, you now have your own
Menyakajaure, sekolah sabar dulu. Masalah, masalah itu mesti bewa. So it's fine to register.
Remember to remove this you have to meaning your ratio. This is important ratio.
Menyakajaure.
All right, everybody, can we switch to the last problem on page 18? Just go to page 18. Question 9 in paper 2015. Right? That will be our last problem. So, colleagues, facilitators, just help them again through that. But give them a few minutes to start and see what they come up with.
Akho nusa yena.
Your question is okay. Est-ce que tu vas dire à comme you have waited 2 minutes.
Sweet. Anasema
right, level 7. Just note that I think the problem with the line from the center to the midpoint may cause some issues, but there are some conceptual stuff that you need to watch out for. All right, and the one is that if you have AB over CD is equal to 7 over 15, right? Or it could even be, if you want to, 14 over 30. All right? What you have here is a fraction, it's a ratio, right? You cannot say AB is equal to 7 and CD is equal to 15 unless it's stated that that length is 7 centimeters. All right? That's the difference. When you work with a ratio, which is a fraction, you cannot make that assumption. And why? Because it's an equivalent fraction. That thing could be 7 or it could be 14, the actual length, right? We don't know that. So you can't make the assumption that that length is equal to that and that length is equal to that. Just be very careful of that. That's one of the dangers working with ratio. All right? So colleagues, just make sure that some of our students now, by the way, what is sometimes very strange is that sometimes, and I think it may happen in this problem, we make that statement, but you get the right answer. That is what we call a fluke. All right, it's just a coincidence. All right, but it's not true in general. So just be careful of that. All right, we thought we needed to highlight that. All right, thank you.
Ananga kira not straight, not zero. Kawa phone na so. Kawa kuri cha. Alex, if it really more, if it it's your own. Without these two, living out. Yeah. I think that's great. Yeah, they can be. Hey, for that one, miaka yetu Which one do you want to be attending? Which comes draw a line from that's
But 1.3 again. Means that TK versus AK. Because we have to prove for it. K2 is going to be K3. Yeah. So, improve that. Ka go ding dictionary ke bile gore TAK ke cycle quadrant. So, before that, I can remember gore TB le TA le tangent. So, go gore A3 ke kana le B2.
that's too complete.
And then it is gonna K2 again. Ke kana le B2. Yeah, in this little segment. Therefore, K2 is gonna be A3. And then right over you do that thing. And then right go K3 very look at what you go really gonna be A3. That same segment here. Like so therefore what are we going to get gonna put both ultimately gonna be A3.
All right, our facilitators, teachers, just check with each of the groups that you are.